tasks. Most users of SolidWorks quickly learn about the relationships between part, assembly, and drawing files. We all come to realize that assemblies and drawings have built-in pointers that allow these documents to find their relevant parts. If these built-in pointers are not sound, your assemblies and drawings are rendered useless. Simply put, to avoid file management problems, your task as a SolidWorks user is to make sure you preserve the integrity of the built-in pointers. You have to make sure that no matter what you do, whether you're renaming a file, copying a file, creating a new revision of a file, and so on, your assemblies and drawings must be able to find their correct parts. In this lesson, I'd like to go through some of the ways that we users manage to break pointers. We'll begin with the changing of names. Here, I have an assembly with 3 components: Part 1, Part 2, and Part 3. What I'd like to do is change the name of Part 3 to Part 3A. To do this, I'll close the assembly and view the same files in Windows Explorer. I'll right-click on Part 3 and select Rename. I'll add the letter A to the end, and I'm done. Now back in SolidWorks, I'll reopen the assembly, and of course, we have a problem. What happened here is that this assembly has a pointer looking for Part 3. Since Part 3 no longer exists, the pointer is now broken. A similar procedure that leads to a broken pointer is to move a file using Windows Explorer. In Windows Explorer, I'll cut and paste Part 2 into a new directory. I'll call it Target Folder 1. Now that I've done this, I'll return to SolidWorks and once again open Assembly 1. Now the assembly reports a problem in finding Part 2 and Part 3, so I have 2 broken pointers. Let's look now at making a copy of a file, and this is typically done when attempting to create a revision of a part. In Windows Explorer, I'll create a new folder called Target Folder 2. I'll copy Part 1 and paste it into the new target folder. Next, I'll make a simple change by adding a rectangular cut through the center. I'll save the file and close it. Now I'll open Assembly 1 again. The pointer to Part 2 is still broken, as is the pointer to Part 3. And as you can see, Part 1 is still the original version, not the one I just created with the cut in it. While the Part 1 pointer is still valid, it's pointing at the wrong file. Now these are simple examples of how assemblies can either lose their referenced parts, or simply point at the wrong ones. Of course, since I'm thoroughly familiar with what I've done in this example, I can simply click Browse when opening the assembly to find the correct files and essentially repair the broken pointers. I can even change the Part 1 pointer to look at the correct modified file. However, in many cases you won't be very familiar with the assembly. It could be that you haven't worked on the assembly in a long time, or maybe someone else has built the assembly and then turned it over to you. In such cases, browsing for replacement parts can lead to more trouble. What if you browse and select the wrong part? Maybe one that's on your local disk instead of the network directory, or even an older revision of the same component. In the next few lessons, we'll take a look at the proper methods for renaming, copying, and moving SolidWorks files while ensuring the integrity of the built-in pointers is preserved. In the previous lesson, we discussed how assemblies and drawings have built-in pointers that allow these documents to find their parts. It can be helpful to see these pointers so you understand why an assembly is failing to find its parts, or why the wrong version of part is being displayed. When you open an assembly, if you simply select it in the File Open window and click References, SolidWorks will display the pointers built into the assembly file. These are the places where this assembly expects to find its parts. By looking at this listing, you'll immediately know if your assembly is trying to find components in places where it shouldn't be, such as a network directory instead of your local disk. Once you open the assembly, you can also see the built-in pointers by using Find References from the File drop-down menu. And this window is similar to the References window we saw a minute ago, with a few more options here at the bottom. From this window, you can see every part being referenced by your assembly, and you can print or copy the list. You can also use this window to copy files. Say you want to put your assembly and all of its referenced parts into a single folder so you can pass the files along to a vendor. This Copy Files button will allow you to do just that, regardless of where your individual parts are stored. Some can be on your local disk, some on your network. It doesn't make a difference. Copy Files will bring everything into a single location. When I click Copy Files, SolidWorks will open the Pack and Go dialog window. You can choose to include drawings and simulation results, and if you have the PhotoWorks add-in enabled in SolidWorks, you'll also have the option to include any related PhotoWorks files. Any items that have the check next to them will be copied when Pack and Go is finished. If there's any items you do not wish to include, simply uncheck them from the list. Here at the bottom, I can choose to have all of the selected files saved into a folder, or I can have all of the files zipped up together into a zip file. If you're planning on emailing the copied files, I recommend using the Save to Zip File option. When I select it, I'll also have the option of having SolidWorks automatically create an email with the zip file attached. For this example, I'll leave this option unchecked and use the Save to Folder option instead. I'll click the Browse button to specify a location and a name, and click OK. The prefix and suffix checkboxes allow you to give the copied files unique names. This can be helpful so that you know which are the files that are the new copies. Now keep in mind that although the file names of the copied files change, all of the references and pointers will be maintained among the copied assemblies and drawings. Finally, rather than preserving any of the original file's directory structures, I'd like for all the copied files to be in a single folder, so I'll make sure the Flatten to Single Folder option is checked. To finish up, I'll click Save, and all of my files will be copied. If I browse to the new folder, you can see Assembly 1 and its 3 parts have all been copied successfully. Another method available for viewing the pointers or references of an assembly or drawing is to use SolidWorks Explorer. SolidWorks Explorer is a file management tool available within SolidWorks. You'll find it in the Tools drop-down menu. Once you launch SolidWorks Explorer, you'll see this simple search interface. If I click the expand icon, I'll be able to browse to the assembly. Once the file is selected, you'll see a preview in the graphics area. To see the pointers within the assembly, click the References tab. One nice feature within SolidWorks Explorer is that you can not only see parts referenced by assemblies and drawings, but you can go the other way and see whether parts are used in any assemblies or drawings. To do this, I simply select a part file and then click the Where Used tab. Any assemblies or drawings that may be using this part will be listed. And this is important if I plan on renaming or moving this file. I can use this Where Used tool to make sure I won't be breaking any pointers by making changes to this part file. If you want to control what types of references Explorer is looking for and where it's actually looking for them, go to SolidWorks Explorer Options and switch to the References Where Used tab. Here, you can tell Explorer what type of references to look for and add additional locations. Well, now that we understand a bit more about pointers, let's take a look at some specific tasks starting with renaming parts. The need to rename a part file in SolidWorks is quite common. In an earlier lesson on the topic of file relationships, we saw an example of how not to do this. Here, we'll be reviewing a couple of different methods for renaming part files that won't lead to broken references. What I'll be doing here is changing the name of the component called Part 1 in this assembly to an actual part number. The trick to doing this effectively is to change the name but also make sure the assembly is aware that the name has changed. This will eliminate the problem of opening the assembly later and being told that the assembly can't find Part 1. Do I really want to search for it? The first method I'll be using to accomplish this is to simply do a Save As. The key to this working properly is that any documents referencing this file must be open. What I mean is, if I have an assembly where Part 1 is used, it must be open in SolidWorks like it is here. If I have a drawing where Part 1 is used, it must be open in SolidWorks. In fact, I do have a drawing for this part, so I'll open it now. Now that both the assembly and the drawing are open, I'll open Part 1 in its window. I'll click File, Save As, and SolidWorks gives me a warning. I'm being told that by using Save As, the pointers of any open documents will be updated to look at the new file. I'm also told that I can avoid this by using the Save As Copy option. Applying the message to this example, SolidWorks is saying that if I continue with Save As, the assembly and the drawing I have open will be updated, so they point to the newly saved part file. And this is exactly what I'm trying to do, so I'll continue. I'll name the part 123-4 and click Save. At this point, I can close the part and return to the assembly. If I go to the component's properties, notice the assembly is now looking at the new part, 123-4. To update the part name as it appears in the feature tree, I can type it in up here and click OK. Since the pointer within this assembly is changed, I have to click Save, just as if any other change had been made to the assembly. The assembly has now forgotten about Part 1 and now only recognizes component 123-4. Likewise, I can switch over to the drawing and click Save to lock in the new pointer to component 123-4. To make absolutely certain that what I've done has been successful, I'll close both the drawing and the assembly. In the File Open window, I can select the assembly and check its references to confirm I'm now looking at 123-4. The same is true for the drawing. Keep in mind all we've done is create a new component with the correct name, and we've changed the pointers in the assembly and drawing so they find the correct part. However, the original component called Part 1 still exists. It simply isn't being referenced by the other documents. To be thorough, it would be a good idea to delete Part 1 to avoid future confusion, or at least move it to another directory. Two things were important in order for this procedure to work. First, the assembly and drawing that were referencing the part were open in SolidWorks. And second, I used Save As and not Save As Copy. See, this allowed me to rename the part file and at the same time update the assembly and drawing so they'd point at the new file. So when do you use Save As Copy? I find it useful when you're about to branch off of a design and try a new idea. Before you make drastic changes, I recommend creating a backup copy of your part using Save As Copy. This leaves a copy intact that you can return to if your idea doesn't pan out. The Save As procedure I just went through is effective when renaming a part that's not used in many places. A typical case would be during conceptual design, when you haven't yet assigned official part numbers to your models. It's okay to start a design with generic names such as base and cover. Then later, when you're committed to the design, you can actually introduce part numbers using this procedure. In cases you wish to rename a part that may be used in many drawings and many assemblies, you might consider using SolidWorks Explorer instead. Renaming a part in SolidWorks Explorer has the added benefit of searching for other documents, such as assemblies and drawings, that might be affected by the name change. Another benefit is that the entire procedure can be done without opening a single SolidWorks file. Here, I have my simple assembly made up of 3 parts: Part 1, Part 2, and Part 3. I also have a drawing of the component Part 3. What I'll be doing is changing the name of Part 3 and updating both the assembly and the drawing so their pointers will remain intact. The first step is to close all files involved. The one thing you must know about SolidWorks Explorer is that it only works on closed files. Next, I'll launch SolidWorks Explorer and browse for Part 3, the part I wish to rename. To rename a file and update it anywhere the file is used, click on it and select the SolidWorks Rename icon on the mini toolbar. Note that this is not the same as just simply renaming the file name, as you ordinarily would in Windows Explorer. To maintain all of the pointers and references, make sure you click the SolidWorks rename icon. When I do, a window appears showing me everywhere the file is referenced. I'll enter the new name, 456-7. The idea behind where used is for SolidWorks to look at assemblies or drawings, examine their pointers, and see if any of them are looking at a component called Part 3. This way those documents will be notified that Part 3 has changed names, and their pointers will be updated. The scope of the Where Used search is something you control manually. Now this is very important, because if you don't tell SolidWorks to search in the right place, you can easily miss an assembly or drawing. By default, SolidWorks will only look within the folder where the part is saved. If you wish to expand the Where Used search criteria, be sure to set it up in SolidWorks Explorer options. Any document with a check in front of it will be updated, so it looks at the new part name. In this case, I'd like to update both, so I'll leave them checked. All I have to do now is click OK. The part is renamed, and the pointers in both the assembly and drawing have been updated as well. If you'd like to verify this, click Browse to bring up the assembly and show its references. 456-7 is now listed as a reference and not Part 3. In fact, Part 3 no longer exists. SolidWorks Explorer did not create a copy of Part 3 called 456-7. It simply renamed the existing file. In the lesson on file relationships, we saw how something simple like moving or copying a file can lead to trouble if done through Windows Explorer. The main concern is that when a part is moved or copied, an assembly or drawing that is referencing that part is not notified of the change. This means that the next time you open one of these documents, you're likely to find broken references or references pointing to the wrong file. This can be especially troublesome in cases where you're controlling revisions of documents. This is by far one of the more complicated areas of file management within SolidWorks. It's difficult for two reasons: because SolidWorks file relationships must be well understood, and because everyone has their own unique way of working with file revisions. Now, before we go on, let me strongly recommend to those of you working in environments where revision control is going to be a regular part of your day-to-day activities, make your life easier by implementing document control software. Tools such as SolidWorks Workgroup PDM are easy to set up, easy to use, and contrary to what you might expect from a document control tool, it's not going to be intrusive in your day-to-day activities. This recommendation applies even if your company already uses large enterprise-scale document control software. You need a tool that understands the inner workings of SolidWorks files and is going to help you as a designer. Take a look at the partner directory on the SolidWorks website for information on many companies that offer PDM tools. Now, for those of you that insist on managing revisions manually, let's take a look at one example of how this can be done. I have this existing drawing which references an assembly, which in turn references some parts. What I'll be doing is making a change to one of the parts. This change will require that I create a new revision of the part itself, as well as new revisions of the assembly and drawing. I'll be using SolidWorks Explorer to do all of this, so I'll close the drawing file since SolidWorks Explorer only works on closed files. Now, let's begin the process of creating the second revision of our files. I'll start SolidWorks Explorer from the Tools drop-down menu. Next, I'll browse for the drawing called Assembly Drawing. I'll right-click the assembly drawing and select Copy. When I do, I'm prompted to either copy it and optionally copy its references using Pack and Go, or I can do a normal copy and paste it manually. I'll click Yes to use Pack and Go to help me select the files and references I wish to copy. The Pack and Go window will appear, and all of the children of the drawing are listed. You can see in the list on the left that the assembly drawing is at the top of the SolidWorks hierarchy. That is, the assembly drawing is listed above the assembly, which in turn is listed above the individual parts. You'll see in a moment why it's important to start with the file that's at the top of the hierarchy. Of course, if there was no assembly drawing, the top document would be the assembly, and we would start with that file instead. Notice that if I would have started with the assembly, the drawing file would not have been listed here. Here, I can choose which items I wish to copy. Anything with a check next to it will be copied. In this case, the component that is causing the assembly and the assembly drawing to be revised is Part 100. That said, I only need to make a copy of the assembly drawing, the assembly, and Part 100. I do not need to copy Part 200 or Part 300 since they'll be unchanged. Since I'm not making copies of those files, the assembly pointers will point to the new copy of Part 100 and will look to the original folder location for Parts 200 and 300. Next, let's deal with the location and names of the copies that we're about to create. Before I do, I'll give you another recommendation. Since we'll be creating a second version of some of these files, you might be inclined to give them special names with a revision prefix or suffix, such as assembly REV2 or Part 100-2. But I urge you not to include revisions in your file names. While this may be a convenient way for you to distinguish one version of a file from another, this technique will make it very difficult for you to import your data into formal file management software in the future. I recommend instead that you use a new folder for your revisions, leaving the file names the same. Since I want to avoid changing the name of the newly copied files, I won't use the add prefix or add suffix fields. Instead, I'll click the Browse button and create a new folder named Revision 2. This is the destination folder for the children being copied. Now, I click Save. To make sure everything worked out as planned, I'll browse into the Revision 2 folder and click on the assembly drawing. I'll click the References tab, and you can see the assembly being referenced is the one in the Revision 2 folder. If I click the assembly, you can see its references are listed as well. Part 100, the one I intend to change, is in the Revision 2 folder, while the other parts are still being referenced in their original location. One more thing I'd recommend doing is adding a revision property to each of the newly revised files. This can also be done here in SolidWorks Explorer. I'll click the assembly drawing and change to the Properties tab. I'll double-click Add New and type the name of the property, revision in this case, and its value is 2. I'll repeat the process for the assembly, and Part 100. Although these new copies do not contain revision numbers in their file names, they now have an internal property that identifies their revision. As with any other custom property, you can reference the revision in drawing notes, a bill of materials, or wherever else it might be necessary. To conclude this lesson, let me repeat that this is only one example of how to manage revisions. Some of the nice elements of this method are that the file names are preserved, files that are not modified are not unnecessarily duplicated, and you're left with the history of your revisions that you can always go back to. Give these items some consideration if you decide to create your own file management procedures. You'll be glad you did when you implement PDM software in the near future. When working with assemblies, you have the ability to reload components. This allows you to replace components if you need to do so, or simply change the way they were loaded in the first place. For instance, if you work in an environment with other SolidWorks users, you may find yourself working on the same assembly as someone else. Here, I have an assembly open. Suppose another user has to modify the draw bar component. Instead of closing my assembly, I can simply give up write access to the draw bar component by opening it in read-only mode. To do this, just right-click on it in the Feature Manager tree, or in the Graphics window and select Reload. In the Reload dialog box, I'll check the Read-Only option and click OK. If I hover the pointer over the draw bar in the feature tree, you can see I now have it open with read-only access, making it possible for someone else to gain write access to the same file. In addition to reloading components, you can also replace them. In this case, I'd like to replace the component called U-bolt. I'll right-click on it in the Graphics window and select Replace Components. This brings up the Replace Property Manager. You'll notice there's an option to replace all instances. I'm only interested in replacing one instance, so I'll clear this option. Next, I'll click the Browse button and select the component called U-bolt 2. This is the component I'd like to use instead of the original U-bolt. Before clicking OK to complete the replacement, I have two more options. The first has to do with configurations. If the replacement component I'll be using has multiple configurations, I can specify which configuration should be used manually. Or I can have SolidWorks try to match the configuration name used in the original component. In this case, I don't have configurations available, so this option has no effect. The last option is a checkbox labeled Reattach Mates. I'll leave this checked. This will allow me to reuse the mates from the original component. Since the new replacement component is different, the mates might not behave as expected. By using the Reattach Mates option, I'll have an opportunity to attach mates correctly. When I click OK, the Mate Entities Property Manager appears. In this case, the replacement part is similar enough that all three mates are reattached correctly. I'll click OK, and the replacement is complete.